This question is about the magnetic field around a current carrying wire, and you are told that when there is no current passing through the wire, the compass needle point towards north, which is what the compass is designed to do so. And in part A, when the current is switched on with the direction of current shown to be downwards to the bottom of the page, you are to determine what happens to the compass needle and what happens if you put the compass needle below the wire. Now the compass needle is on top of the wire. So we use right hand grip rule, point our thumb along the direction of the current, and this is the direction of magnetic field around the wire. If you look at this part of the magnetic field that I'm circling, which is in front of the wire, is pointing towards the left, and therefore this is the answer to A part 1, where the compass needle is pointing towards the left, which is the west direction. Now, when you put the compass needle behind the wire, we are looking at the magnetic field lines behind the wire, which is over here, and the answer to this is the needle will point towards the right side, which is the east direction. Now, in part B, what happens if there is now an alternating current that is 50 Hertz? So alternating current is a current that changes direction, and in this case, it changes direction 50 times a second. That's the meaning of 50 Hertz. So there are two answers to this. The first one is the needle will oscillate about the vertical line at 50 Hertz, 50 times a second. So if it up, then it will switch to pointing down, switch to pointing up, and you will do this switching 50 times a second. The second answer is more feasible, that because 50 times a second is actually quite fast, therefore what happens is the needle might not even have time to rotate completely, so it will just be stuck. The needle will appear to remain at the vertical direction.